Navigation has developed a worldwide language of terms, techniques, and conventions. To understand modern marine navigation, a navigator must know where these ideas came from. Prime meridians, charts, sailing directions, compasses, logs, nautical units, sailings, earth geometry, and coordinates. A prime meridian is a relatively recent convention. Before the 19th century, cartographers used different starting meridians because longitude could not yet be measured accurately. Ptolemy measured longitude eastward from a line west of the Canary Islands. In 1493, Pope Alexander VI established an Atlantic dividing line between Spanish and Portuguese territories, later used by their cartographers. Other prime meridians followed. Ortelius used the easternmost Cape Verde island in 1570, and John Davis used the Isle of Fez in 1594 because magnetic variation was zero there. Mariners often ignored these standards and used local capes and ports. London's meridian appeared by 1676, and Greenwich gained influence as British sea power grew. The British Nautical Almanac of 1767 strengthened Greenwich, and in 1884, Greenwich was officially adopted as the prime meridian by maritime nations, except for some local harbor chart references. Charts are graphic representations of Earth areas, in digital or paper form, used for marine and air navigation. Nautical charts show features important to mariners. Charts may date back to 600 BC. Stereographic and orthographic projections date from the 2nd century BC. In 1569, Gerardus Mercator published his famous projection, and about 30 years later, Edward Wright corrected the mathematical tables that allowed others to create accurate Mercator charts. It remains the most widely used chart projection. Sailing directions, also called pilots, have existed since at least the 6th century BC. As exploration, trade, and navigational knowledge expanded, these written guides grew through the Middle Ages. French routiers appeared around 1500, while the English called them rudders. In 1584, Lucas Wagenaar published Spiegel der Zeevaart, or The Mariner's Mirror, which became a model for generations and was known to sailors as Wagoners. The magnetic compass is over 1,000 years old. Its origin is uncertain, but Norsemen used it in the 11th century, and Chinese navigators used it at least that early, and probably earlier. Lord Kelvin developed a reliable dry-card marine compass in the 1870s, and the fluid-filled compass became standard in 1906. Variation was clarified in the 18th century by Edmund Halley's South Atlantic expedition. Deviation was known earlier, but better correction came through Matthew Flinders, Sir George Airy, and Lord Kelvin. Iron and steel ships later required the gyrocompass. Foucault created the basic gyroscope in 1852, and Elmer Sperry and Anschutz Kampfe developed electrical gyrocompasses in the early 20th century. Today, ring laser and digital fluxgate compasses are replacing older gyrocompasses, while the magnetic compass remains a vital backup. The log is the mariner's speedometer. Early sailors estimated speed by watching a chip of wood pass along the vessel. Later, they used a wooden board attached to a reel of knotted line. Counting knots paid out during a measured time gave the term knot. Mechanical logs with paddle wheels or rotating spinners appeared around the mid-17th century. The taffrail log was developed in 1878 and is still used in limited cases. Modern logs use electronic sensors, spinning devices that induce electric fields, engine revolution counters, shaft logs, Doppler logs, inertial systems, and satellite systems for accurate speed readings. The common sea distance unit is the nautical mile, now exactly 1,852 meters. Chart depths may be shown in meters, fathoms, or feet. A fathom, equal to 6 feet, has ancient origins. Posidonius reported a depth over 1,000 fathoms in the 2nd century BC. NOAA charts mostly show feet or fathoms, with a small number in meters, while NGA charts are being produced or converted entirely to meters. Sailings are mathematical methods for determining course, distance, and position, with contributions from Thales, Hipparchus, Napier, Wright, and others. These include plane, traverse, parallel, middle latitude, Mercator, and great circle sailings. Earth is an irregular oblate spheroid, flattened at the poles. Geodesy studies its dimensions and flattening, but for most navigation, a spherical Earth is accurate enough. The axis connects the north and south geographic poles. A great circle is formed when a plane cuts through the center of a sphere. It is the largest possible circle and gives the shortest surface route between 2 points. On the spheroidal Earth, the true shortest line is a geodesic, but a great circle is close enough for most navigation. A small circle is formed by a plane that does not pass through the center. A meridian is the upper branch of the half-circle from pole to pole through a point, with the opposite half called the lower branch. A parallel of latitude is a circle parallel to the equator. The equator is a great circle at 0 degrees latitude, dividing the northern and southern hemispheres. The poles are single points at 90 degrees, and all other parallels are small circles. Any position on Earth can be defined by latitude and longitude. Latitude is angular distance north or south of the equator, measured along a meridian from 0 degrees to 90 degrees and labeled N or S. Difference of latitude, or D-lat, is the arc between two parallels. It is the numerical difference if both places are on the same side of the equator, and the sum if they are on opposite sides. Mid-latitude is half the sum for two places on the same side across the equator. It is half the difference and takes the name of the place farther from the equator. Longitude is angular distance east or west from the prime meridian through 180 degrees, labeled E or W. Difference of longitude, or D-low, is the shorter arc between meridians. Subtract longitudes on the same side of Greenwich. Add them on opposite sides unless the sum exceeds 180 degrees, then subtract from 360 degrees. Departure is the east-west distance between meridians along a parallel, usually in nautical miles. Unlike D-low, departure decreases as latitude increases.